There we go. It just wasn't connected to the server, whatever. Okay, so the chapter 11, oh shoot, I don't have my book. But it's a two-dimensional square, or two-dimensional list. So I'm gonna have a list of lists, and like I have on the board, each row of the square is gonna be its own list. So then I'm gonna go boom and boom. So my square 1 needs to be 4, 9, 2. Then I need 3, 5, 7, and 8, 1, 6. Yes, Thorn.
Should you put a comma after the middle row?
Oh, I do. Thank you. Now, for my second square, I'm going to copy this and paste it, and all I need to change is that. Because a magic square is only a magic square if every row, every column, and the two diagonals all equal the same number. So by changing 9 to 10, 10 plus 5 plus 1 is 16, doesn't equal everything else, so we're good. Yes, Thorn.
Doesn't the magic square have to have only 1 through 9 in it?
There we go.
I didn't. The diagonals on the top one.
Oh, yeah, that was part of it, but it won't be worth. It'd be like half a point. Because if you get everything else, then that means you get the concept. So, what we're going to do. So now we need to add all these up. So what we're going to do is we're going to go top row equals the sum. Now, how would I get the sum of a list inside of a list? Because typically I would have sum of list name. How do I get this right here? Thorn?
Square 1 bracket 0.
Square 1 brackets 0. Correct. What would be my mid row? Actually, it's not square 1. Who can see the error? Hang on. See. Gabe, do you have headphones in? Do you have a headphone in? Please take it out. Thank you. It's not square 1. We'll get an error.
Square 2.
It's not square 2. We'll get an error.
Square.
Just square. Why do you say that?
Because that's what's going to get you into the
Yep, that's exactly it. This is the variable that's being passed that stands for square 1 and square 2. So this would be square. What square would this be? For the middle row. Yep. Oh, not 9. Bracket. Yep. And bottom row. And what's this one going to be?
Square 2.
Square brackets 2. Yep. All right. So now we got to do columns. So column. So we're going to do r underscore column equals what? Did I hear a laugh over there? There can be no laughter in my classroom.
Okay. Yes, Mr. Filter.
There you go. Sorry.
You laughed.
I know. All right. So what's my right column going to be? I'm going to need three different things. All right, because I need to add 4, 3, and 8. How does that do? Yeah, that equals 15. How do I get just this number? What would be the index of just number 4? Just 0? Brackets 0. Of what?
Square 1.
Square like this?
Sure.
No.
Isn't it just square?
Well, square 0 is this whole thing. So what was that, Adam?
Well, it's like 2 zeros.
Yep, that's it. Then what do we need to do? We need to get 3. So that's going to be square
1.
1, 0, and then square. Yep, 2, 0. mcol is going to be. What can I do real quick? I'm going to, well, change all the zeros to 1. Wait, which zeros?
The second one.
This one?
No.
I mean that one?
Yeah.
1, 1, 1. And then the left column. Oop. Then which one do I change here?
0 to 2.
And now we're gonna go, yes.
Would R call actually be L call?
Yeah.
Oh, yeah, you're right. Good catch. Glad you caught that mistake. That test, it wasn't a mistake. I was making sure you guys were paying attention.
Yes.
So now we're gonna go up diag, and we're gonna have diag and down diag. So my up diagonal is 8, 5, 2, and my down diag is 4, 5, 6. So what am I gonna do for that? I'm obviously gonna need to do essentially what I did up here. But what numbers am I gonna have to use for the indexes? Right, so how do I get those? Say what, Jason?
Well, if you're starting from the top left and going down, it's going to be 0, 0, 1, 1, 2, 2.
1, 1. Okay, so that's gonna be for my down diagonal.
Oh, I didn't know.
Yeah, so down diagonal is the one that goes down.
Oh,
Up diagonal is the one that goes
Yeah, that
up.
makes sense.
So then what's my up diagonal? Gabe, you got an idea?
First one would be 0, 2, 1, 1, 2, 0.
0, 2, 1, 1. What was the last one?
2, 0.
2, 0,
No,
0, 2.
0.
What? No. It's the same thing as the first one.
Oh, yeah, so 0. Oh, you guys did. So 0, 2 is this one. 1, 1 is this one. What's this one?
2, 2.
2, 0. Well, then I'll change this one just so for me. 2, 0. So now we need to know if what makes this a magic square.
They're all.
Jason, are you on your phone?
No.
Okay. How do we figure out if this is a magic square or not?
If they all add up to be the same.
If they all equal each other. So if top underscore row equal.
I had if it doesn't equal, and then I had so if it doesn't equal, and this doesn't, or this doesn't equal this and this. There's a lot of writing.
Yeah. Well, so you just had if top row doesn't equal what? Like mid row?
Mid row, or top row doesn't equal bottom row, or top row doesn't equal L column.
So you just had a lot of if else. Okay. Thorn, what'd you have?
I just had, well, I wrote my code a little different, but in this case it would be if top row equal, mid row equal, bottom row, and you just go through all the variables.
You could do that. I'm thinking, what if we did total equals a list, and then we do, actually we could do total equal Who just said? What'd you say, Gabe?
It's just Eric is. Eric, I don't look at his code. It's really smart how he did his for this part.
How'd you do this?
I just added up all the variables in the if statement, then divided it by 8, and if it's equal to one of them, then it is a magic square.
That's what I was. Yeah, I was gonna do that, but with using a list in the and right? So now we're gonna do if the sum of total divided by the length of total equal top underscore row, print magic square, else print no magic square. All right, you guys think that'll work? Let's find out. There we go. Do you guys understand how this works?
Yeah.
Because the sum of it divided by the length of it, if they're all the same number, if I have 10 tens, that's what, 100. If I divide 100 by 10, I get 10. So if the sum of it divided by the length of it equals the same number, then it's a magic square. As opposed to, if top row equals mid row or equals this, like, that totally works. It just is a lot of if else, and the fewer things you have to type, the simpler code is, right? Okay. Any questions?
Is there a possibility with a total divided by the length, like where the top row maybe isn't, where they aren't all the same, but the top row equals the total, the sum divided by the length?
Can you say that again?
Is there a possibility where the top, where they don't all equal the same thing, but the top row equals the sum divided by the length? So then there's
Maybe.
I mean, just by random,
yeah.
it's very minimal, but you can on purpose make that happen. But it's very.
But there's so
Well, you could also do and you could do this a few, mid row, and you could do that a couple times, and that would probably prevent that from happening. But you probably could very well, be able to do that. Excuse me. Let's make sure it still works. All right, magic square, no magic square. All right, so quiz time.